Hello dear students, welcome once again to our channel Maths in Minutes with Priya. Today is clip 38, Problems on Numbers Part 1. In clip 36 and 37, we have covered how to solve simultaneous equations. I also covered few word problems. We learned 3 procedures. So I hope by this time you are expert in solving simultaneous problems. We are going to use it today on this topic, problems on numbers. So let's begin today's topic. Before moving towards actual problem, let us revise few things. If I talk about number 37, I'm talking here about number 37. In 37, all of you know that tens place is 3 and units place is 7, and that's how I write the number 3, 7, 37. But how do I arrive at its value? I have to multiply this tens digit number 3 by 10 and then I add 7 to it, and that's how I get 37. Do you agree? 37 is 3 into 10, that is tens digit, tens place digit. I multiplied by 10 and then I add units place. Similarly, suppose it was 68, then what you will do? 6 is tens place, so 6 into 10, that is 60, and then you will add 8 and that's how it becomes 68, right? So value of number is arrived by multiplying tens place by 10 and then adding units place. Clear? But if I talk about sum of the digits, SUM sum of the digits. Here what are the digits? Digits are not 30 and 7. Digits are 3 and 7 and their sum is 10. 3 plus 7 is 10. So value of number and sum of digits are entirely different than each other. Getting the difference? Many students get confused with this term, sum of the digits and value of the number. So they are totally different. If I talk about product of digits, digits are 3 and 7 and their product is 21. So value of number, sum of digits and product of digits are altogether different than each other. I hope the point is very clear. So instead of talking about actual numbers, if I talk about x and y, we are going to need it while solving the sums. So please pay attention. If I say in a number, in a 2-digit number, tens place is x and units place is y, then how do I arrive at value of that number? Same as this. Multiply tens digit by 10, so it becomes 10x, and add units place y, so it becomes 10x plus y. Value of this number is 10x plus y. Here when I say 37, I can write it as 37, but when I say x and y, I cannot write it as xy because xy is product. I cannot write it as xy. I have to write this number as 10x plus y. Very clear? When tens place is x and units place is y, the number is 10x plus y. But if I talk about sum of the digits, here what are the digits? Digits are x and y, same as here. Digits are 3 and 7. Digits are not 30 and 7. Digits are 3 and 7. So here also digits are x and y. So their sum will be x plus y and their product will be xy. This basic concept very clear? Now what if I exchange the digits? Always there are the problems about exchanging the digits, you must have noticed in your exercises. So if I exchange the digits, like now 7 comes in tens place, 3 comes in units place, the number becomes 73. 37 now becomes 73. And how do I arrive at its value? It's again the same. Whatever is there in tens place, I have to multiply it by 10 and I have to add units place. That's how it becomes 73. Do you agree? So same way here, if I exchange the digits, y comes here and x comes here, Then what will be the value? Tens place I have to multiply by 10. So this will be 10y, and add units place, so it will be xy. So now 10x plus y changes to 10y plus x when I exchange the digits. Very clear? If I talk about sum of the digits, now I have exchanged the digits, but still sum of the digits will be same. 7 plus 3, that is 10. Isn't it? Here digits were 3 and 7, and now 7 and 3. So sum remains the same. Value changes. From 37 it has become 73. But sum of the digits remains the same. Here also sum of the digits will be same only. Product of digits, 7 3s are 21. Here also 21. So product of digit is also not changing. Sum of digit not changing. Product of digit also not changing. What changes is value of number. So when I exchange the digits, value of the number changes, but sum of the digits does not change. I hope this point is very clear. If it is not clear, please watch this part again, because every now and then we are going to need this concept in today's video. We are going to solve 2-digit, 3-digit number also. So please be sure that you understand this concept. Now let's move towards the problem. After exchanging the units digit and tens digit, the new number is 27 more than the old number. The ratio of old number to new number is 4:7. Find the old number. This is the original number with which we started. So how we can start? Let the tens place be x. Let the units place be y. We will start like this. So what will be old number? Old number is 10x plus y. Do you agree? According to this principle, it is 10x plus y. Now they are saying when I exchange the digit, after exchanging what will happen? Y will come here and x will go there. So what will be new number? New number will be 10y plus x. We saw here already. It becomes 10y plus x, new number. Now they are saying the new number is 27 more than the old number. That means new number and old number, their difference is 27. Isn't it? This is 27 more. So when I subtract this old number from new number, I'll get 27. This is 27 more than this. So I subtracted old number from new number. New number, old number. Carry out this subtraction in your notebook. When I open the bracket, x minus 10x is minus 9x. 10y minus y is plus 9y equal to 27. Isn't it? I can divide whole equation by 9. 9 is there everywhere. When I divide minus 9x by 9, I get minus x. Here I'll get y, and here I'll get 3. I have divided left hand side and right hand side by 9. Getting it? So what I basically did is I took 9 outside as a common factor and I divided both sides by 9. So I get minus x plus y is equal to 3. I will call it as equation number 1. So I need one more relation now. And what is that relation? The ratio of old number to new number is 4:7. What is old number? 10x plus y. New number is 10y plus x, and their ratio is 4:7. So what can I do? I can do cross multiplication, and then I can simplify and form one more equation. I am doing it in my working. You also do it in your notebook, and then we will match it. I did the cross multiplication like this, and I opened the brackets. Then I get 70x plus 7y is equal to 40y plus 4x. I take all x and y on left hand side. So 70x minus 4x becomes 66x. 7y minus 40y becomes minus 33y is equal to 0. I have taken everything there. So on the right hand side it's 0. I can take 33 as common factor. So this becomes 2x minus y is equal to 0. That's how I get my second equation. This is my first equation, minus x plus y is equal to 3, and this is second equation. So you can easily see which method is best here. Elimination method. Minus y and plus y can get totally eliminated when I add. So I'm going to add 1 and 2. This is 1 and this is 2. Minus x plus 2x is x. Y minus y eliminated. 3 plus 0. This is addition. 3 plus 0 is 3. So I have value of x as 3. If I substitute it here in equation 2, is equal to 0. Sorry, this is 0. So 6 minus y is equal to 0. Therefore y is equal to 6. What is x? X is tens place and y is units place, that we have already assumed. So that means the original number is 36. That is the question. What is the original number? It is 36. Very clear? You need to be very fast in cross multiplication, solving, forming the equation, and then in simultaneous equations. Like I said, in between three methods, substitution, elimination and shortcut, you are going to decide which method is best when. If you want to know more about it, please watch earlier 2 videos about simultaneous equation part 1 and part 2. In that we have covered which method is to be used when. So your answer is 36. Let's move to next example. On exchanging units place and tens place in a 2-digit number, the difference between original number and new number is 45. The sum of the digits is 9. Find the original number. So I am going to begin in same way. Tens place, let me assume it as x, and units place as y. So old number will be 10x plus y. And they have given sum of the digits is 9. So I have my first equation, x plus y is equal to 9. Let me call it 1. Then what happens? On exchanging, that means now this will be y and this will be x. So new number is 10y plus x. I think you don't need any explanation in this now. We have already solved one example and we have explained it in very detail. So this is new number. And the difference between them is 45. So here if you observe in the very first example that we solved, they had given us that new number is 27 more than old number. So we knew which number is more, old number is more or new number is more. But here have they said anything like this? They are saying the difference between these two numbers is 45. So we don't know whether old number is more or new number is more. We don't know. So we have to check both the possibilities and find our number. So let's see how to do it. So now I am considering first possibility, old number is more than new number, and in second possibility I will try new number is more than old number. So let's begin with this. Old number more than new number, and their difference is 45. That means old number minus new number will be 45. Old number is more, that I have assumed. So when I solve this, what will I get when I open the bracket? This will be minus x, isn't it? So 10x minus x, that is 9x. Y minus 10y is minus 9y is equal to 45. If I take 9 as common factor and divide both sides by 9, I will get x minus y is equal to 5. This will be my equation number 2. Now look at this equation 1 and equation 2. What do you observe? If I add them, what will happen? Y and minus y will be eliminated and I will be left with 2x, isn't it? So let's do it. 1 plus 2. I am solving now simultaneous equations. See, in exam you can do it orally because here it's oral calculation only, but this is all I am writing just to explain. You keep your rough work minimum to save the time, but if you are in school, I think you need to show all these steps. So when I add, I get 2x is equal to 14. That means x is equal to 7. When I substitute it here, x equal to 7, I get y is equal to 2. Substitute x equal to 7. 7 minus y is 5. That means y is 2. So my number becomes 72. Tens place is x, units place is 2, number is 72. So with this first possibility, old number more than new number, the old number is 72. Getting it? So what will be new number? New number is just exchange of digits. So new number will be 27. Getting it? Now if I solve with the other possibility, that new number more than old number, let's see what answer do we get. Now I am assuming new number is more than old number and their difference is 45. So I am carrying out here the subtraction. New number minus old number is 45. So when I open the bracket, x minus 10x, that is minus 9x, 10y minus y is plus 9y is equal to 45. If I divide whole equation by 9, I will get minus x plus y is equal to 5. Let me call it as equation number 2. For this possibility, equation number 2. And what was my original equation? The sum of the digits is 9. That was x plus y equal to 9. That we have already seen. Equation 1. So when I observe this, what do I get? If I add, x will be eliminated and I will be left with y. So add 1 and 2. X will be eliminated. 2y is 14. So y is 7. When I substitute y equal to 7 here, x plus 7 is equal to 9. So what will be x? X will be 2. So the number will be 27. X is tens place, units place is y. So number will be 27. And if I exchange the digits, number will be 72. Right? So when we solve this with first possibility, we got the number as 72, and when we solved with the second possibility, we got the number as 27. In both cases, either 72 or 27, the sum of digits is 9, and when I exchange, the difference will be 45. So in case of both of these numbers, the conditions are satisfied. So your answer is either 72 or 27. And the options can be something like this. A is 72, B is 27, C is either A or B, and D is none of this. So what answer will you mark? You will mark C. It's either A or B, because we need to consider both the possibilities. They haven't mentioned which number is bigger, so we have to consider both the possibilities, and your answer is either A or B. Now whenever we solve number on problems like this, many students prefer to first see the options and go in the reverse way. So use 72 whether conditions are satisfied, use 27 whether conditions are satisfied. Yes, they are satisfied. That means answer is either A or B. You can do like this even for the remaining questions also. Suppose there are 5 options, then students what they do, with every option they find whether the conditions given in the problem are satisfied, and whatever answer satisfies the condition they mark that as answer, and that's how they save the time of this forming simultaneous equations and solving them. So that is also one way of solving. But if suppose there are 5 options and the 5th option is right, suppose, then what they need to do, the students which like to solve in this way, for every A, B, C, D, every time they have to see whether the questions given, the conditions given in the questions are matching or not, and by that time the other students directly gets the answer by forming this equation. So it's up to you which way you need to use and where you are comfortable. But I have purposely shown you this method in detail so that in exam if you get a problem like this with either A or B, then what to do, you must understand that, and that's why I have covered this detailed procedure. It's actually very easy example. You can try it on your own also. Let's move to next example. In a 3-digit number, hundreds digit is twice units digit. If hundreds digit and units digit are exchanged, the new number is 198 less than original number. If tens digit and units digit are exchanged, the new number is 63 less than the original number. Find the original number. So this is a question based on 3-digit number. And for 3-digit number also, what can be the procedure? See, when I say 3-digit number, for example, if I say 532, then how do you arrive at this number? You have to multiply hundreds place by 100, tens place by 10, and then add units place, and that's how it becomes 532. Correct? So whatever digit in hundreds place multiplied by 100, whatever digits in tens place multiplied by 10, and then add units place, that's how we arrive at a 3-digit number. So same principle now we are going to use here also. So I am writing here hundreds place, tens place, and units place. Now one way of solving is, you can assume this as x, y and z and write the number as 100x plus 10y plus z. That is one way of solving. But generally in this type of questions, 3-digit, they give you relation between these digits. So what I prefer is, instead of assuming 3 variables and 3 unknowns and then forming the equation and make it complicated, in the first stage only I am going to use the relation given. Let's see what I mean by this. They are saying hundreds digit is twice units digit. So if I assume units digit as x, hundreds digit will be 2x, isn't it? If units digit is x, because hundreds digit is twice the units digit. So if this is x, this is 2x. If hundreds and unit digits are exchanged, so some other conditions. So for 10, I am going to assume y. So instead of assuming x, y and z, I am assuming 2x, y and x. So I am reducing number of unknowns. So what will be the number? Hundreds place is multiplied by 100. So 2x into 100 plus y will be multiplied by 10 because it's tens place, and then units place will be added. This is 200x and this is 100. This is x. So this is 201x plus 10y. So the original number is this. I hope it is clear. And now they are saying hundreds digit and units digit are exchanged and the new number is 198 less than original. So let me see what's happening. Hundreds digit and units digit are exchanged. So what is happening? Hundreds and units. So now hundreds becomes x, units digit becomes 2x. They haven't mentioned anything about y. So y remains as it is. So what is this new number formed? Multiply this by 100, this by 10 because it is tens place, and add units digit. So this is 102x plus 10y, and they are saying the new number is 198 less than original. So this minus this is 198 that is given to us. So let us form one equation. This is original, this is new, this is 198. Let's solve this. 201 minus 102, this is 99x. 10y minus 10y eliminated is equal to 198. So what is x? X is 2. 198 divided by 99, that is 2. So you already have your units place and hundreds place. Getting it? In original number, units place is 2. So this is 2. Hundreds place is 2x. So 4. Tens place we don't know. So the number is 4 something 2. Are you getting it? Now for finding this y, we need one more relation. Now they are saying if tens digit and units digit are exchanged, the new number is 63 less than original. Tens and units are now exchanged. Tens and units. So right now forget this. Let's concentrate on this. Tens and units are exchanged. So x comes here, y goes there. So what will be new number? This is now 10x, x and y. 100, tens, units. Tens and units are exchanged. So this becomes x, this becomes y. And the new number will be 100, 2x into 100, that is 200x plus multiply this by 10, so 10x plus y, that is 210x plus y. This is new number. And what is the relation? The new number formed is 63 less than original. Now we have this relation, original minus new is 63. Original we already have, new we just form, it is 63. So solve this, open the bracket, 201 minus 210, this will be minus 9x. 10y minus y is plus 9y is equal to 63. If I take 9 as common factor, it will be minus x plus y is equal to 7. Now x I already have. What is x? 2. I already found it. So minus 2 plus y is equal to 7. So what will be y? Take 2 here, minus 2 here. So y will be 9. So what is your number? We already found 4 and 2. Y was missing, and that also we now found. So your answer is 492. Easy? See, when you assume 2 variables instead of 3, it becomes easier. So whatever relation is given to you in the problem itself, use it in the first stage and form your equations. Then it becomes easy. If you haven't understood this example, please watch it again. It's very easy actually, not at all difficult. It's the only 2 relationships are given. In the first stage, hundreds and tens are exchanged. In second stage, tens and units are exchanged. So 2 times you need to form the equation and solve it. Just take one care that these are our original assumptions, x, y and 2x, and this is our original number. So mark it clearly, this is original. This is new number formed by the first condition, these two were exchanged. Then this is new number formed by the second condition when these two were exchanged. So mark it carefully, 1, 2, 3, so that in your brain you shouldn't get confused which is original and which is new by which condition. You shouldn't be confused because you have solved it so clearly, so you will get the answer in very easy manner. It's just that differentiate it clearly by calling it equation 1, equation 2, equation 3, so that everything becomes very clear. Before moving to next example, let's revise this formula. It is required for next example. Let's understand with a simple division. If I divide 23 by 4, what do I get? 4 5s are 20 and remainder will be 3. This is known as divisor. The number with which we divide, this is divisor. The number that is divided is known as dividend. This is quotient and this is remainder. And how do we arrive at 23? 4 5s are 20, 20 plus 3 is 23. Same manner, quotient into divisor plus remainder. Quotient into divisor plus remainder is dividend. So please remember this formula. We require it for many word problems. So based on this formula, now let's solve one word problem. Sum of two numbers when divided by 9, the quotient is 12 and remainder is 2. The difference of two numbers when divided by 7, the quotient is 11 and remainder is 5. What are the numbers? So I am going to assume two numbers as x and y, and where x is more than y. Let the two numbers be x and y, and let one number x be more than y. Now they are saying sum of two numbers when divided by 9. So x plus y is divided. Correct? So x plus y becomes dividend. It is divided. Then what happens? Quotient is 12. So when divided by 9, so divisor becomes 9 and quotient becomes 12. This is dividend. Quotient is 12. Divisor is 9. And the remainder is 2. So plus 2. We are applying same formula. Dividend is equal to quotient into divisor plus remainder. 12 9s are 108 plus 2 is 110. So x plus y is equal to 110. This is your equation number 1. The difference of two numbers when divided by 7. Here I am assuming x more than y. So difference will be x minus y. And it is divided. So now it is dividend. It is divided by which number? By 7. So 7 becomes divisor. Quotient is 11. So 7 into 11. Plus remainder was 5. So plus 5. Dividend, quotient, divisor plus remainder. 77 plus 5. 77 plus 5 is 82. X minus y is 82. This is your equation number 2. We want x and y. So plus y minus y. What I can do? I can just add equation 1 and 2. X plus x will be 2x. Y will be eliminated. 110 plus 82 is 192. So what will be x? Just carry out this division. X will be 96. With this you can find value of y. Substitute here. 96 plus y is equal to 110. Therefore y is 14. So your two numbers are 96 and 14. So though this example looks little difficult, it's actually easiest example of this particular session because we have this direct formula. Getting it? So with this direct formula, form these two equations and solve it simultaneously. You will have your answer ready. So today we solved some word problems on simultaneous equation. They were based on numbers. In next session also we are going to solve some simultaneous equation problem, that I'll cover some average problem, some ages problem also. If you haven't yet subscribed to my channel, please do so. Maths in Minutes with Priya. It's absolutely free. So see you in next video. Till then, stay happy, stay blessed. Follow all the tips that I have been giving during these videos about simultaneous equation, divisibility rules, tables, factorization. You need each and every tip for solving the examples. So please keep studying, keep watching. Bye for today.